Good afternoon, Algebra 1 students. So today I would like to talk about the first chapter of Algebra 1. So it's kind of like a chapter review. I really want you guys to have a great start with the new term or the new semester or whatever that you're doing, either like refreshing the old concept or getting started with chapter 1. This video, it would be the best benefit for you, to refresh some of the concept or things that you're going to be doing, or maybe having like a preview with the new unit. So chapter 1 for Algebra 1, it's all about solving equation. So it's all about solving linear equation, not the system yet, just the linear equation. Linear, that means the highest power of the variable, it's always 1. So here's some of the sample problems. So now let's take a look at that, the number 2 and 3. So for solving the one-step equation. So let me just snip this 2 problem and then I'll put it right here on the whiteboard. So the first one is 2.6 equals negative 0.2 times t. As you may notice that t is the variable. So anytime they see things like this, you want to find out the operations. So according to the operation here, it's considered multiplication. So whatever the multiplication that the operation we find out, we always want to do the inverse operation. So the inverse operation of multiplication is division. So we divide both sides by negative 0.2. Okay, so divide both sides by negative 0.2. And then we end up with t equals, and for those students might be using calculator for this, but instead of using calculator for this, we can always simplify it by converting it to fractions. So we do know that 2.6 over negative 0.2. So one decimal place, top and bottom, we can just move the decimal place from the left hand side to the right hand side, or simply just multiply top and the bottom decimals by 10. So we got 26 over negative 2. And then from there, we just want to reduce. So half of 26, 13. So positive divided by negative, negative. So it's negative 13. Another thing that you can consider doing here, simply plugging the number back to the original equation and then check the work. So negative 0.2 times 13, so which is what? 2.6. And then the other one similar, divided by negative 5. So the operation is division, so we want to find out the inverse operations. So we multiply both sides by negative 5. So multiply both sides by negative 5. So we got negative 5 times 5. So that's negative 1. And negative negative got canceled, so we just got n. So negative 2 times negative 5, which is 10. Okay, how simple is that? Okay, so now let's see what else that we have for the other section here. Going back to this page. So 1.2 is solving the multiple step equation. So let's do some of the challenging one, such as like number 8 and 9, and also 11. So I'll just pull those out. So for number 8, and it's about fractions again. So for those students who might be freaking out with fractions a little bit, fraction is actually pretty friendly. So there's an easy way to get rid of the fraction. So 3/2 times the quantity of x minus 2 minus 5 equals 19. So before you do anything here, you can always multiply, just add 5 on both sides first. Again, find out the inverse operations of the given subtraction. So add 5 both sides, so we do have 3/2 times the quantity of x minus 2 equals 19 plus 5, which is 24. And then 3/2, you might be wondering, can we get rid of 3/2, or do we need to distribute? You can do it either way, but the best way to do it is to get the reciprocals of 3/2, because once we multiply by the reciprocals of the fractions, we basically can cancel out the fraction here. So 3/2 times 2/3, cross cancel, so it's gone. There's no more fractions. But what about the right hand side? So 24 divided by 3, so that would be 8. So cross cancel, so we got 8 times 2, which is 16. So now what's left here? It's just x minus 2 equals 16. And then add 2 on both sides. So we do have x equals 18. Again, it's pretty straightforward. So instead of multiplying out the number, so add 5 first, and then multiply the reciprocals of the fractions. Okay, so it's easier to do it that way. And now, what about the other one like this? So we got 6 equals 1/5 w plus 7 over 5w minus 4. So first thing that you want to find out, the like terms. So you may notice that 1/5 w, 7 over 5th w. So combine them, so we do have a over 5w, combine the like terms. And then f4 both sides. So once you f4 both sides, so we do have 10 equals a over 5 times w. And then in order to get rid of that a over 5, we multiply by the reciprocal, just like what we did for the previous problem. So multiply by 5 over 8, both sides. Cross cancel, cross cancel. And now we got 50 over 8. The way to multiply the fractions, straight across. And now you might want to be checking the word right here. So this one, it's not the simplest form. So even number, top and the bottom, so we can reduce down the number by either 2 or 4. So divided by 4, top and the bottom. So 50 divided by 4, which is not divisible. So just divided by 2. So we got 25 over 4. Okay, so reduce. Divided by 2, top and the bottom. Okay, so that's what we found. And now, what about this kind of polygon? So 1, 2, 3, 4, 5. So it's a 5-sided polygon, which is called a pentagon. Okay, so for that one, and you might be wondering, how do you set things up and then solve for x? So now, let me just clear off this one a little bit. Okay, so clear notation. So this one, we do know that it's a pentagon, so that means we need to add all those angles together, all the interior angles. So we got x minus 30. And how many x minus 30 do we have? We got 1, 2, 3, 3 of those. So multiply by 3. And then how many x's do we have? 2x. So once we combine them all together, the sum of the angle measure is 540. So set equal to 540. And now from here, we want to solve for the multiple step equation. So first thing that I want to do, distribute. There's no fraction here, so we can distribute, because that is easier. So 3x minus 90 plus 2x equals 540. And then 3x, 2x, the like terms, combine them. So we got 5x minus 90. So that equals 540. So find out the operation. So subtraction, we want to get the inverse operation. So add 90 on both sides. So we got 5x equals 540 plus 90, which is 630. And then for 5, multiplication, inverse operation, divided by 5. So x, so 630 divided by 5 without the calculator, so just do the long division. So 1 times 5, that's 5, subtract, get a remainder, so 1, bring down to 3. So 2 times 5, that's 10, subtract, get a new remainder, so it's 3. Bring down to 0, so 6 times 5, which is 30. So it's 126. So x is 126. Okay, so now let's see what else that we have with the rest of this. So going back to that page. So we got 1.2. Now what about 1.3? So solving the equation with variables on both sides. So anytime that you want to solve for the equation with variables on both sides, so one thing that you want to do, you want to collect the variables together. Okay, so let's do this one. Okay, so this one is given as 3 times the quantity of n plus 4, so that equals 1/2 times the quantity of 6n plus 4. So again, fractions that we have, no need to worry about that, just distribute. So 3n, 3 times 4, so then that would be 12. 1/2 times 6n, so half of 6, that's 3. So 3n, 1/2 of 4, which is 2. So you may notice that it's the same coefficient with the same variable. So once you subtract 3n on both sides, so this one, the variable will get cancelled. And what's left here is 12 equals 2. But 12 cannot be 2. That doesn't make sense. So see anything like that, that means this one would be no solution. Okay, so see that the number on both sides, they're not equal. The variable got cancelled. That means no solution. But now let's do another one like this. Okay, so what about for number 13? Okay, so number 13, let's see right here. Okay, Okay, so for number 14, that would be no solution. And 13. So what happens if I distribute that 5 there? So this will be 5 plus 5x. So that equals 5x plus 5. Well, this one is pretty much the same kind of expression on both sides. If that's the case, or you just cancel out the 5x, subtract 5x both sides, so we do have 5 plus 5. If that's the same kind of expression or same kind of number on both sides, so that means this one would be infinitely many solution. So that means x can be any real number. Okay, so or x can be any real number. Okay, so now let's see the next section here, 1.4, solving absolute value equations. A lot of students having trouble with solving absolute value equations. So now let's see, 16 and 17. So normally your teacher won't give you like 17, but it's good to think about that with the absolute value on both sides. So for those you might be wondering what we can do. Okay, so now let's put it out here. Okay, so started off with number 16. So to solve for absolute value equations, so one thing that we need to do is to isolate the absolute value quantity. So add 9. While adding 9 here, that means we want to subtract 9 both sides. So we got negative 2 absolute value of 5w minus 7. So that equals negative 16. Because that's negative 7 minus 9. So negative 16. Then divided by negative 2. So we do have absolute value of 5w minus 7 equals 8. Now, if you see the absolute value equals to a negative number, that means no solution. But this one is a positive, so it could be considered negative and positive. Because absolute value is just finding the distance from 0 of the absolute value quantity, either coming from the left or coming from the right. So coming from the left, which is negative, so 5w minus 7 equals negative 8. And then the other side right here, 5w minus 7 equals 8. Oops, excuse me. So let me just rewrite this part right here. So 5w minus 7, so that equals 8. And then you want to solve for those two equations here. So as 7 both sides. So we do have 5w equals negative 1. Divided by 5. So we got w equals negative 1/5. And then for the positive, so we S7 both sides. So we got 5w equals 15. And then divided by 5 both sides. So we do have w equals 3. So absolute value, normally we do end up with 2 solutions. And now, what about the one with the absolute value on both sides? So this one, again, without the absolute value, so we do have x minus 2, so that equals positive 4 plus x. The negative, then that would be x minus 2 equals negative the quantity of 4 plus x. And then you just solve for x. So subtract x on both sides here, you'll see that x and x got cancelled. So negative 2 equals 4. Wait a minute, that doesn't make sense. So that would be no solution for this part. And then for the negative, so we got x minus 2, so that equals negative 4 minus x. The negative 1 distribute. So x plus x, then we do have 2x. And then add 2 on both sides. So we do have negative 4 plus 2, which is negative 2. Divided by 2. So we got x equals negative 1. So there's only one solution for this part. Okay, so now let's see what else that we have for the rest of the unit here. And the other one is writing the equation in formula. So in other words, that solving the literal equation. So this one looks like there's a lot of variable involved here, but keep that in mind. Whatever the variable that you isolate, that means that is the only variable, okay? So let's do some example like this one here. So like 20 and 21, or perhaps 22 or 23. Okay, let's do 20 and 21 first. So this one solved the literal equation for y, so that means y would be the variable. Okay, so now let's see right here. Okay, so if y is the variable, so that means, let's just rewrite it. Okay, so we got ax minus 3, so that equals 5 plus 4 times y. So y, I just want to put in a different color. So in order to isolate that y here, so that means I need to get rid of that 5, and also I need to get rid of that 4. So 5, it's addition, so we started with the operation, the inverse operation, so subtract 5 both sides. So now we got ax minus 3 minus 5. So negative 3 minus 5, then that'd be negative 8. So it's ax minus 8. So what's left here? It's just 4y. Again, y, I just want to put it with different color. Okay, let's see this one. And then for 4, divided by 4 both sides. So that means y equals ax divided by 4, 2x. Negative 8 divided by 4, negative 2. So y equals 2x minus 2. And then here's another one. So you might be wondering, how do we solve for y here? So for y, compare and contrast. So y looks like that one is the greatest common factor, so we can put it out first. So you might be wondering, 3 is also the greatest common factor. Indeed, yes, 3 is also the greatest common factor, but just take out that y because that's what you want to isolate. So y times the quantity of, again, I just want to use different color for that variable. So y times the quantity of 9 plus 3x. As you can see, that here is 9 times the quantity of 9 plus 3x. So in order to get rid of that 9 plus 3x, you divide it both sides. Divide that 9 plus 3x on both sides. So y, we got 8 over 9 plus 3x. Okay, so solving for the literal equation. And now let's see what else that we have for this section here. So the pyramid, this one is finding that find the height. Okay, and the other one is also find the exact value of the height of the pyramid. Okay, so certainly we can do that. Okay, so one of the word problem. Okay, so let's just put it out here. So this one's kind of like a geometry word problem here. So the volume of the pyramid, it's always given by the formula, volume 1/3 times capital B times H. So capital B, that means the area of the base, and whereas B is the area of the base and H is the height. Solve for the formula for H. Okay? So one thing at a time, so start with that V equals 1/3 times B times H, because we want to solve for H. That's why I'm going to write it with different color. So one thing that you want to do, so you want to get that 1/3 first. So multiply both sides by 3. So we got 3v equals b times h. And then for that capital B, simply just divide it by capital B on both sides. So that means h equals 3v divided by b. And then for part B, find the height. Okay, so you want to find the exact value for the height. So basically plug in a number. So we do have the height equals 3v. So 3 times the volume, 216, divided by the area of the base, which is 36. So before you divide it, this one looks like we can reduce. So we do know that 36 times 6, so that's 216. So this one reduced by 6. So we got 3 times 6, which is what, 18. So the height, it's about 18 centimeters with the unit. Alright. So another word problem that's quite similar. So the way to convert that from degree of Kelvin to degree of Fahrenheit. So solve for K. Okay, so let's write that one too, since this one is the last one. So this one's more like a general science word problem, converting temperature from degree of Kelvin to degree of Celsius. Okay, so here's the formula for degree of Kelvin to degree of Fahrenheit. It's 9 over 5 times K times the quantity of K minus 273.15 plus 32. So solve for K. So let me just rewrite it. So f equals 9 over 5 times, so k, again using different color because that's the variable we want to isolate, minus 273.15 plus 32. So again, one thing at a time. If you see anything that's kind of considered further away from the variable, so like the separated constant here, so that's the first thing you want to cancel. So the way to do it, simply subtract 32 both sides. So we do have f minus 32 equals 9 over 5 times the quantity of k minus 273.15. And then 9 over 5 without distributing the number, so we want to multiply by the reciprocal. So the reciprocals of the 9 over 5, which is 5 over 9. So multiply both sides by 5 over 9. So again, if you multiply this one on the left hand side, that means you multiply by the exact quantity. So put in the parentheses. So 5, 5, cross cancel, 9, 9, cross cancel. So we got 5 over 9 times the quantity of f minus 32. So that equals k minus 273.15. And then last but not least, you want to add 273.15 on both sides. So it's 5 over 9 times f minus 32 plus 273.15. So that equals the degree of Kelvin, just Kelvin. So this one is for A. And now what about for B? Convert 180 degree Fahrenheit to Kelvin. Okay, so plug in the number. So we got 5 over 9 times 180 minus 32 plus 273.15. So that equals K. So 180 minus 32, then that would give you 148 times 5 over 9 plus 273.15. Just carry down those numbers. So 9, does that 9 go into 148? Okay, so let's see right here. So it looks like this one, so probably want to put it into the calculator to find out exactly what that is. Okay, so it looks like it's not divisible. So 148 divided by 9. So so we got 5, 58, and then 6 times 9, 54. Subtract. So we got 4, bring down to 0. So 4 times 9, 36. So this one is like 6.4 blah blah blah, repeat it. So it's better for you to put it into the calculator to find out exactly what that is. Okay, so once you come up with the solution, you want to round it to the nearest 100. Okay, anytime they see things that you have to round it to near something, it's always a calculated problem. So don't forget about the unit. The unit for that is going to be Kelvin. Okay, so the number. Alright, so thank you for watching the video today. So any questions that you have, so you're more than welcome to put in the comments or the questions on the YouTube comment bar, and I try to reply that as soon as I can. Alright, so I'll see you guys next time. You guys have a great one. Take care.